This video accompanies learning IoT with Python and Raspberry Pi. In this video, you will learn how to control a Hue light bulb using Python code and your Raspberry Pi. In addition, you will learn how to modify this code to turn a Hue light bulb on and off in response to sensor readings. In order to do this project, you will need a Raspberry Pi 4 or 3 and the usual peripherals, that is to say a monitor, a keyboard, and a mouse, one Philips Hue light bulb, one Philips Hue Bridge, a Sense hat, and a patch cable to connect the Hue Bridge to your router. It is also possible to connect the Hue Bridge to a wireless access point, which is configured as a repeater for a hotspot instead of using a router. Since this requires additional steps, we will not show the configuration in this video lecture. Instead, we'll defer the steps for using a hotspot in a separate video. Screw a Hue light bulb into a lamp that is not dimmable and that is not a three-way lamp, and turn on the switch. You'll need to configure the Hue Bridge to recognize a light bulb. Download and install the Hue app on your smartphone. Click on the Hue app, click on Create Room, Create Living Room, and Room Type Living Room. Then click on the check mark. Click on the three vertical dots. Click on Light Setup. Click on Add Light, and you can add a serial number for the light or click on Search. You should find one new light. Click on the Living Room and under Light Selection, add Hue White Lamp 1. Click on the checkbox. If you want to add additional lamps, perform the same steps. You will need to configure a static IP address for the Hue Bridge. Click on Settings. Click on Hue Bridges. Click on the lowercase I to view the IP address. Click on Network Settings. You want this IP address to be a static IP address. Click on Network Settings. Turn off DHCP and set the IP address of the Hue Bridge to 192.168.0.100. Leave the net mask as 255.255.255.0 and the gateway as 192.168.0.1. If you have a different subnet from the 192.168.0.0 subnet, you'll need to set an address and a gateway for your network. Next, we'll write the code to turn the Hue light bulb off and on. We'll be using the encode method of the JSONEncoder class to encode the data that is to be transmitted to the Hue Bridge. The two commands that we'll send to the Hue Bridge are to turn the light on and off. Each will have the form of a one-item dictionary that has been put into JSON string representation. The Raspberry Pi communicates with the Hue Bridge in a manner similar to opening a web page. Hence, we'll use the urlopen function of the urllib.request module to open the URL that is composed in part of the address of the Hue Bridge, a key, and the number of the Hue light bulb. The URL function can take a request object that represents the URL, the data that is to be passed, and the HTTP method used to send the data. We'll begin by importing the modules necessary for the Raspberry Pi to communicate with the Hue Bridge, as well as the sleep function from the time module. http://192.168.0.100 is the base URL. This is the IP address of the Hue Bridge. For now, we'll assign an empty string to key and light number. After we enter the code, we'll determine the values these two variables should be assigned. We'll define the send event method to handle sending the turn on and turn off commands. The send event function is defined with two parameters, essentially the URL to which a command is to be sent and the data which will be of the dictionary type. In addition, because we are testing this code, we'll call the print function from within the send event function. If this were production code, we would return the relevant object. The encode method is used to encode the data as a JSON string. We create an instance of the request class by passing link, the JSON string, and put for the identifier method. Next, we pass the request object as an argument to the urlopen function. We use a for loop to iterate over the object that is returned by the urlopen function. Following the sendEvent function definition is an assignment statement and a try except statement. The variable URL is assigned the concatenated base URL API /key /lights /light number and /state. The sendEvent function is called with the URL passed as the first argument and a one-item dictionary with on as the key and true as the value, passed as the second argument. The sleep function is called with 10 as the argument, so the light bulb will stay on for 10 seconds. The sendEvent function is again called, but this time passing as the second argument a dictionary with on as the key and false as the value. The try except statement handles a keyboard interrupt in case the user presses Ctrl+C. We'll use a generic exception clause to handle any other kind of runtime error. We'll save the code. Next, we'll need to determine the key and the light bulb number. Now that we've entered the code to turn the Hue light bulb on and off, let's connect the bridge. So we'll connect the Hue Bridge using a patch cable to the LAN port of our wireless access point. Click on the terminal and enter R-A. We'll see the IP address of the Hue Bridge is 192.168.0.100. Let's go into the browser and connect up to the Hue Bridge. Enter http://192.168.0.100/debug/clip.html. We'll put the URL as /API and we'll enter the message body as device type in double quotes, colon, double quotes again, my_Hue_app #iPhone Peter. Close double quote, close curly bracket, and click on Post. Now you'll notice that we get an error message, link button not pressed. This is for security purposes to ensure that we have physical access to the Hue Bridge. So I'm going to press the button again, and I'm going to post again. Now this time, you'll see that we get success. Now we need this username as the key for our application. So I'm going to copy and paste that as my key. Now I also want to see what lights I have. So I entered 192.168.0.100/API/ the username that I just obtained /lights. And I'll notice that light 1 is mentioned as having state on of false, and light 2 has state of on, also false. So that means both of the lights are turned on. We're only going to be using one light bulb. We're going to be using light bulb 1. Let's paste in the key and set the light number to 1. So let's run the script that'll turn the light bulb on for 10 seconds and then turn the light bulb off. So we'll see that we connected up to the Hue light bulb using that username, specifying that we were connecting to light number 1, set on to true. We got a response back from the Hue Bridge. Then we set the on property to be false. And when we connected up again to the Hue Bridge, we've got that we were successfully turned the light off, and then we're completed. Let's turn on the Hue light bulb in response to a change in an environmental reading. Next, we'll write a script to turn the light on and off if the humidity exceeds the initial humidity by 3%. We'll do File and Save As to save this file with a different name. We'll import the SenseHat class from the sense_hat package. Assign an instance of the SenseHat class to the variable sense. Make an initial humidity reading by calling the getHumidity method. Use an infinite loop in order to continually read in the humidity. Use an if statement to compare the current humidity with the initial humidity. If the current humidity is 3% greater than the initial humidity, then we'll call the send event function twice. Once to turn the light bulb on and once to turn the light bulb off. Call the sleep function so that the light bulb stays on for 5 seconds. We'll sleep for 1 second before calling the getHumidity method again. I'm going to cup my hands over the SenseHat to increase the humidity. And that turns on the light bulb. Now imagine that you aren't monitoring the humidity with the Sense hat. You could monitor a passive infrared sensor. And if there was motion, then send the event. It'll turn on the Hue light bulb.
For links to where you can buy Learning IoT with Python and Raspberry Pi, go to www.learningiot.net.